Okay, so lesson number 7.2. What we're going to do is we're going to take the absolute values that we learned yesterday, right? What's the definition of absolute value? The distance from 0, and it always has to be positive. Now, could your answer that when you actually calculated it be negative? Yes, because we did some yesterday, right? But the distance cannot be negative. Okay. So what we're going to do now is we're going to do absolute value functions. We're going to take absolute values, x's and y's, we're going to graph them. Okay, now this goes back to when we actually graphed right back to the beginning of the course, right? We graphed linear, and we also graphed quadratic. Remember this stuff? Okay, the only difference is we're going to start to do absolute values. So what it is every graph that we're going to do, when it's absolute value, it's called a piecewise function. Piecewise means pieces, right? Here's two pieces of the graph. That's all we're going to do. We're going to put them together. Okay. Now, if I was to graph just this, y equals x, basic linear equation, linear, right? Linear line. What does it look like? A line. Thank you. Like, we know that already. It's a line and it's straight.
That is what it looks like.
I know, but where does it go through? The origin, there we go. Goes to the origin, right? Goes up 1 over 1, up 1 over 1, up 1 over 1, right? So if I was to actually draw this out, right? I'll do it in a different color here. If I were to draw this out, it would actually look like this. Isn't it? Is that y equals x, that red line?
Yeah, I go either way. Or...
Y equals x, right? Is that correct? That's what it would look like. Okay? Now, if we want to take the absolute value of it, now look, y equals the absolute value of x. What does that mean about y now? It's what? It's positive. Every time, it's always positive. Think about this for a minute. Just watch. If x is 0, what's y? 0. Okay, so that works. If x is 1, what's y? 1, so that one works. If x is 2, y is? If x is 3, y is? Okay, so basically what we're saying is this part of the graph, does it change at all? No, it stays the same for an absolute value. Okay, now, think about this one for a minute. Let's put this back line. If x is negative 1, so right here, if x is negative 1, what does y have to be? Positive 1, right? Because the absolute value of negative 1 is positive 1. Okay? What if x is negative 2? Y has to be positive 2. Okay.
The absolute value of x. Right?
No, it's y equals the absolute value of x. So think about this for a minute, guys. Here's the red line is our normal y equals x. When we take the absolute value of it, what have we done to this whole quadrant down here? Quadrant 4, or quadrant 3, sorry. Moved it where? Into quadrant 2. And actually what we did is we actually flipped it, didn't we? Can you see that? If I take this point here flips up to here, this point flips up to here. Does it just flip up into the axis? Okay. So for instance, I'll just on the side here, if I gave you any graph, watch, and I'll just give you a straight linear one. There's the linear one. Okay? What would the absolute value of that look like? What would change? This, where would it go? Up into here, wouldn't it? So then it would go like this. That would be the absolute value. Is that correct? Okay. What if I gave you, hang on. Let's do this one here. What if I gave you that one? What would change if I gave you the absolute value? This bottom part would go up there. That's the absolute value. Pretty easy, eh? Everything below the x-axis now flips into the above the x-axis. Everything below the x-axis flips to everything above the x-axis. Well, because it's positive. Y cannot be negative, right? Is there any case where you could take the absolute value of a number and make y equal negative? No. Okay. So piecewise means it's made up of pieces, and in this case, 2 pieces. Now let's look at the graph here. Okay. This first part of the graph, do you see it? From 0 and every x is positive and y is positive. Is that the original graph? Right? Is that the original part of this? Okay, so there it is there. Y equals x. That's this part right here. There's our original graph. Right? That's it there. Okay? Now, look at this point. What point did it start at? 0, and it included 0 and everything greater than 0. Basically, it means everything to the right and up. Right? Okay? That's one part of the piecewise. Now, the other parts, look here. Here's the original, the red one. This is the old part, and what happened to it? It flipped up. Here's the easiest way to do this. The first part of the piecewise is always just the plain old positive. Right? The second part of the piecewise is you take that sucker and make it negative. That's it. That's all you have to remember. The first piecewise is just the regular one. The second one you make negative. Okay, so think about this. So y equals negative x. That's basically everything over here. Because negative x is everything to the left of the origin. And this was greater than or equal to 0, so this one is less than 0. Here's how it's always going to work. Your first one is always your original one. And it always is greater than or less than equal to, right? That's the equal to. The next one is always the opposite direction. And it doesn't include the equal to. You'll see in a minute, it's always the same. Always, always, always the same. Okay? That's a piecewise because it's made up of 2 pieces. You'll see this in a minute once we do. We're going to do 2 examples. We're going to do a linear and we're going to do a quadratic, okay? Here's the first linear one. Here's the first linear one. Graph an absolute value function of the form y equals ax plus b. What's this known as? Y equals ax plus b. What's that form? What? No, it's not standard form. Standard is ax squared plus bx plus c equals 0. That's standard form. Slope-intercept form, right? And y equals mx plus b. Right? You don't always have to use those letters. Okay. So what we want to do is there's the graph right there. Y equals the absolute value of 2x minus 3. How do you think we do this? What do you think the easiest way to graph this thing would be? No. But what do you graph? What are you trying to graph first off? No, we know. We can figure that out in a minute. No. Guys, look here. Look back at the original equation. What would be the easiest way to graph this? Would it be the easiest way is to graph the red line? Yeah. And then take everything that's in the below x and flip it into above x, right? Is that the way to do it? Okay, think about this one for a second. What would we graph first then? What do you want to graph? Just graph the regular old y equals 2x minus 3. Can you do that? Yeah. Did we do tons of that? Uh-huh. Okay. If you graph that, that's the first place you want to start. Graph the original equation. So let's do that. I gave you a table there, didn't I? On your sheet? Okay, here it is. Okay. How do we graph this? I don't know. I'll forget. I'm dumb.
Okay, take 2 times 0.
No. How do you graph slope-intercept? Rise over run, and what do you always start with? The y-intercept. You always start with the y-intercept. And the y-intercept in this case is -3. So there is the y-intercept right there. Beautiful. Okay, -3. What's the slope? It is, what is it? 2 over 1. So that means you go up 2 over 1. Up 2 over 1. Think of it like a set of stairs, right? You go up 2 stairs over 1 stair. Up 2 stairs over 1. So just do that. Up 2 over 1, put a dot. 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 That's the slope, right? You could go backwards too if you wanted. You could go down 2 over 1, down 2 over 1. Right? Because the slope doesn't change, right? The slope is 2. It means it goes up 2 and over. Okay. So can we put in a line now? What point? Up 2 over 1. Up 2 over 1. What's the slope? 2. 2 over 1. Rise over run. Rise over run. Rise over run. Rise over run. Slope. What is the slope? 2. That means you go up 2. What's that 2 over? 1 over 1. Up 2 over 1. So you figure out slope. Okay, let's fill in the lines. Okay, there it is. So what equation is that right there on the board? Y equals 2x minus 3. That's the equation, right? Do you agree with that? That's our basic equation. What do you want? Right? Oh, yeah. Now, what we want to do is we want to graph the absolute value of this. So it's really quite easy to do. What part of this is which part of this is below the x-axis? The bottom part. So basically you take this whole thing and where's it going? You flip it up, right? So this point goes way up to the top. This point, what would this point be if we flip it up? Right now it's 0, negative 3. What point would it be when we flip it up? 0, positive 3. Oh, that's nice to know, eh? Y-intercepts are easy to flip, aren't they? Okay, I'm going to do this in a different color just so you can see it. So this point here would be that point there. And then it would go up 2 over 1, right? Up 2 over 1, up 2 over 1. Is that correct? Okay. Now, what's the hard part? No. Which one? There's no vertex. We're not dealing with a quadratic, so.
Vertex where it starts.
That's for a quadratic. No, the origin is where the x and the y-axis cross each other. What's it called, guys? The point we're looking for.
Yeah, the one that we're looking for.
X-intercept. We're looking for the x-intercept, right? Isn't that the point that's the same on both of them, right? Because that's the point where it's right on the x-axis. Anything below it then gets flipped above it, and anything that was above it is still the same. How do we find? No, we're not doing it graphing-wise. Use your brain. Think how to do this mathematically. No, that's what he just said. I don't want you to go down 2 over 1, down 2 over 1. What? Makes a V, but anyway. No, because we're going to get rid of the bottom part. That part does not exist anymore. Guys, how do we find the x-intercept? Come on, use your math brains. Guys, what's the value of y at the x-intercept? 0. Oh, can we do that? So basically what we're saying is here's y equals 2x minus 3. What are we making y equal to? 0. Oh, does this look familiar, by the way? Isn't this solving for x? Isn't this like solutions when we did quadratics, when we did linears, and we solved for x? What? So 2x minus... Oh.
So you use those little lines to the absolute value?
No, because this is just the point where we're just trying to find the x-intercept. All we're looking for here is the x-intercept. Okay, that's all we're looking for, right? X-intercept. Okay, move the 3 to the other side, equals 2x. X equals 3 over 2. So what's that point, right? What point is it? Right there. 1.5 basically, isn't it? I know, but the questions you're going to get, you actually have to figure them out mathematically. Okay, so what does this line actually look like then? This line here is really not there anymore, is it? Why did I draw that line in originally? So you can see what we're going to take out of the below the x-axis and flip to above the x-axis. So the line we're actually going to draw in, red will work. We'll just go solid. Here we go. So there's this part. Let me fix this line. Hang on. Just need to adjust it over a bit. Whoa, that's not what I wanted to adjust. That. And that. Okay. So that, right there, that is your graphing of the absolute value of y equals 2x minus 3. Everything that was in below the x-axis now goes to above the x-axis. Is that correct? Okay. Now we gotta do some other stuff. We gotta state the domain and the range. You guys hate this, but it's not going away. Told you it's coming back. We're going to do it both ways. Okay. Guys, what's domain and range? Domain is x, range is what? Now, guys, look at the domain. Negative infinity to positive infinity. That's one way of writing it. So you say domain, right, round brackets, negative infinity to positive infinity. That's one way. That's interval notation, right? How do you do it as roster notation or set notation? How do you do it? X is all elements of R, right? It's all real numbers, basically. It's everything. Every number you can conceive of for X, it's part of that system. It's not stupid. Yeah, do you have to know both? Yes, you do, because you don't know which one your prof is going to give you in university. Yeah, they can force you to do whatever they want. And they'll laugh at you and kick you out of class, so don't even try that. Okay, domain, guys, domain is pretty much always that, isn't it? Have you noticed that? Domain is always that. Range is always the one that screws people up. Okay, now, range in this case is really quite easy. It's got to be, does it include 0? Yeah, because it hits that point, and it's everything that's greater than 0, right? It does hit 0. It hits 0 here on the y-axis, right? Touches that point, right? Remember, this was like a quadratic. Remember when we did discriminants with quadratic? It could either be 2 points, no points, or 1 point. This is hitting at 1 point, right? It's actually hitting at 1 point. Okay, so range in this case is either 0, and does it square around brackets for 0? Square brackets because it includes that point and goes to positive infinity. That's one of them. Or the other way of writing it is y. Y is greater than or equal to 0, and y is all elements of R, which is all real numbers. Okay, you're going to have to leave if you're not going to pay attention. Yeah, seriously. Okay. Guys, really, you should understand both ways for domain and range. They're really not that bad. Okay? Okay, anyway. Okay. Now, please don't spin that ruler around. Thank you. This part, guys, this part is probably the easiest part. What we're going to do is we're going to name the piece y. Okay? We're going to basically, you're going to tell me that one equation, you're going to break it into 2 pieces. Okay? Here's how you do it. Really quite easy. Put down the y equals right at the beginning like this. Open up your big Charlie Q's like this because you need a large set of brackets because you're going to put in 2 equations. Shh, please. Quiet. This is really important. If you miss this, you'll miss so many marks. If you miss this next part. Okay. Here's how you do it. It's super easy. Super, super easy. Ignore the absolute value brackets for a minute. What is the first equation? Y equals 2x minus 3. That's what you do. You just write in the equation just like it is. Bang, there it is. That's the first equation. Then the second part of it is you take that thing, put regular brackets around it, and make it negative. That's it. No, you just put it in brackets and make it negative. That's all you do. This is the first part. This is the second part. That's all you do. Every single time. Even with quadratics, you'll see. But the only difference with quadratics is we're not done yet. We have to now tell everybody what part is what. Okay, now look at the original equation. Y equals 2x minus 3. Of that graph right there, which part of it, the left or the right, is the original 2x minus 3? The right-hand side. And what point did it start at? No, careful. Didn't start at 0. It started at 1.5. It started at 3 over 2. Does it include 3 over 2? Yes, you always do that on the first one. You include it on the first one. So if x is greater than or equal to what? 3 over 2. That's all you do.
What's the I ask for?
If. One of those big words there. You haven't seen it before, so I know. Okay. Now look, that just make sure that's clear. So the 2x minus 3 is the original equation, and it starts at 3 over 2 and goes that way. So it's greater than or equal to. So for the next part, the part we did negative, it's everything over to the left. At what point does it start? Does it include that point this time? No, it doesn't. Because we included that point on this one. So if x is less than 3 over 2, it's going to be the same pattern over and over again. You put the original down without the absolute values. The second part of it, you put it in brackets to make it negative. That's it. This one is always to whatever the right was. It includes that point. This one is to the, in this case, the left, and it doesn't include that point. It's the same every time. The original includes the point. The negative does not. The original includes the point. The negative does not. Okay? Does that make sense? It will make more sense when you actually start drawing these out. So the key to this, guys, and let's make sure this is clear. When you're doing a linear equation, graph the linear, pretend there's no absolute value. Just graph it like you normally would. Then you take everything that was in the below the x and you flip it to above the x. Okay? Then you can create your piecewise. And the piecewise is simple. The original, the negative, includes the point, doesn't include the point. Okay, now, let's try quadratic. What? Yeah. Okay, so what we have there is we have a quadratic. Hot water is not gas. Okay. What do you think? What do you think you do on this one? Guys, just take a wild guess.
You would factor it, and then
No.
you would,
No.
I don't know.
Guys, graph the original quadratic. Could you do that? There's slope. It's not linear. Guys, we did this. We graphed quadratic so many times. There are multiple ways of graphing this.
That was like so long ago.
Well, you figure out whether it's a mountain or a valley, right? Could you find the x-intercepts? Could you find the y-intercepts? Could you put it in vertex form if you want? You could do any of this stuff. Would it help you? Sure, why not? So take a look at, ignore the absolute value sides. Y equals basically negative x squared plus 2x plus 8. What do you know right away? How do you know it's a mountain? It's a negative. It opens down. Okay, that's some good. It's good information. It's a mountain, right? It opens down because it's a negative.
Put the negative x squared, is that why?
Yeah, because it's negative. Mountain max, that's right. Do you remember this now? Okay. What else do we know based on that? That's in standard form, by the way. What else do we know? What's the y-intercept? 8. Remember that? If it's in standard form, we can look at that and we can find out that the y-intercept is 8. Okay, that's not bad. Okay, so let's see what we have. So, did I give you space to graph this? Oh, I did give you a graph. Look at that. Okay, let's graph this. Let's put some of the information on. So what is the y-intercept? 1, 2, 3, 4, 5, 6, 7, 8. So there it is. And it opens down. So, we obviously need to find the... No, we'll get to that yet. Come on, Mountain Max. What do we need to find?
The thing.
The thing. Yeah, that helps me not. The vertex!
It's 8 coming through.
Now. No, that's the y-intercept. It's going to be up there. It's going to be above it someplace, right? It's either going to be, we don't know, the vertex is either going to be on the left or the right. Could we complete the square to find the vertex? Yes, we could. What's an easier way to find the vertex?
Just ask the teacher.
No, don't ask the teacher. No. guys, super easy little formula that you find the... Oh. No, not the quadratic. Oh. If you want to find the vertex, use x equals negative b over 2a. Remember this? This gives you the x value of the vertex. Then if you know the x value of the vertex, how do you find the y value? No, you plug it in. What?
Negative b over 2a.
That's what I said.
Yeah, it's a whole two thing. That's everything.
Okay, let's fill out what we know.
Negative 2 over negative 2.
What is b? So it's negative 2 over 2 times negative 1, which is negative 2 over negative 2, which is 1. How do we find the y value? Plug it back into the original. The original, what is it? Y equals negative x squared. What is it? Plus 2x plus 8. Okay, wherever you see an x, what do you replace it with? So y equals negative 1 squared plus 2 times 1 plus 8. Negative 1 squared, well, negative 1 plus 2 is positive 1 plus 8 is 9. So what's the vertex? 1, 9. Do you want to practice? Well, we have time. Do you want to practice completing the square on there?
No.
Well, too bad. We're going to do it anyway. Okay.
Why did you ask?
Because it was a rhetorical question.
And no one asked anymore. They would do it today.
Well, it's fun that way.
This way.
You can,
Then why are we doing it the other way?
because you got to remember how to do it.
Well, if I don't want to do it, honestly, I probably don't know how to do it.
Yeah, I don't really. If you
I guarantee you remember how to do this.
If you showed me, then I'd do it.
No, you can do it. Okay, let's complete. Guys, that's the vertex. That's one way of finding it, right? Let's complete the square because that's useful too. Okay, so here's the original. Y equals negative x equals, oops. I never remember what I'm actually writing down here. There it is. Y equals negative x squared plus 2x plus 8. What's the first thing you do if you're going to complete the square? Take out the negative. Very good. Y equals negative. We're taking that out. So x squared minus 2x. Now hang on. Does the 8 change at all? Am I taking the 8 out of here or am I putting it way outside the bracket? Putting it way out there so it doesn't change. So what I'm doing is I'm adding 2 things there. Do you remember this stuff now? Hang on. What number do we take to divide by 2? Negative 2. What? No, you said 2. Okay, so negative 2 divided by 2, and then we're going to square that, right? What's negative 2 divided by 2? Negative 1 squared is 1. Okay. So, if we add 1 here, to normally keep it in balance because it's on the same side of the equation, if we add 1 here, we normally subtract 1 there. It's on the same side of the equation, right? So we add 1 because it gets outside the brackets and gets attacked by a negative. So we're going to add 1 on this side. Okay, so y equals negative x minus 1 squared, right? You don't even have to look. You just look at the minus 1 plus 9. So what's the vertex? 1, 9.
Oh, I remember this now. When we made 1.
No, what number do you plug in that to make it 0?
Oh,
Right? No, it was necessary because you have to remember how to do it. I think